Today we're going to learn about chain rule problems. Let's say we have a problem like this. Solve d dx of e to the 4x times 7x squared plus 5x cubed to the third power. And b, find d dx of 12 times in parentheses 9x to the fourth plus 5 all cubed. So let's start by understanding how to solve this problem. So whenever we have a composition of functions, which means that whenever we have functions that are put together, one inside of another, we have to use something called the chain rule to find the derivative. So the chain rule states that if g of x is equal to f of h of x, then g prime of x is equal to f prime of h of x times h prime of x. So this is what the chain rule says. In other words, the chain rule says that if you have a function, g of x, which has an outer function and an inner function, the derivative of g of x is equal to the derivative of the outer function, which still includes the inner function, but times the derivative of the inner function. And you can have more than two functions. The chain rule only specifies two, but if you have more than two, you use something called the nested chain rule, which is the same thing as the chain rule, just applied over and over again. So let's start with problem A. First, let's isolate the different functions. We have e to the x, we have 4x cubed, and then we have this most inner function, which is 7x squared plus 5x cubed. So this is the outer function, this is the middle function, and this is the inner function. So let's start. First we take the derivative of the outer function, which is e to the x. We know that the derivative of e to the x is e to the x. So we have e times, instead of having e to the x, remember how the chain rule had f prime of h of x. So now we plug in the middle and the inner function. So e to the 4 times 7x squared plus 5x cubed power times the derivative of the middle function now. The derivative of the middle function, which is 4x cubed, would be, bringing the 3 down, would become 12x squared. So we have times 12, this is no more in the exponent, times 12. Instead of having x, we put the inner function, times 7x squared, 7x squared plus 5x cubed all squared. Now we have to multiply this by the derivative of the next function, which is 7x squared plus 5x cubed. The derivative of 7x squared plus 5x cubed we know would be 14x plus 15x squared. So this is the answer to problem A. The answer to problem A is e to the 4 times 7x squared plus 5x cubed power times 12 times 7x squared plus 5x cubed squared times 14x plus 15x squared. Now let's move on to problem B. In problem B, let's isolate the functions. We have 12x cubed, which is the outer function, and then we have 9x to the fourth plus 5. Which is the inner function. So now let's use the chain rule to find the derivative of this function. So we have 12x cubed, which becomes 3 times 12 is 36x squared. So 36 times, let's write this in black, we get 36 times x, which we know would be 9x to the 4th plus 5, squared, because the exponent decreases by 1, squared, times the derivative of the inner function, which is 9x to the 4th plus 5. The derivative of 9x to the 4th plus 5 would be 4 times 9 is 36 x cubed, because we know that the derivative of 5 is 0, so we don't add anything. So the answer to part B is 36 times 9x to the 4th plus 5 squared times 36x cubed.